Engineering Challenges 1. We will look at what causes an earthquake, structural and geotechnical components used in earthquake engineering, the Puebla 2017 earthquake, the outcome of structures and slopes we tested in the lab. Earthquakes are sudden violent shakings of the ground, typically causing great destruction as a result of movement within the Earth's crust or volcanic action. This is most commonly caused by tectonic plates moving and colliding, which releases energy in waves. S&P waves are released from the epicenter. These seismic waves travel to the surface and instigate surface waves like Rayleigh and Love waves. These waves will exert a force on the structures we build and introduce a lateral load or shear force, and in result cause soft story failure. Mexico is one of the world's most seismically active regions, sitting atop several intersecting tectonic plates. It also has soft soil made up of sand and clay, which amplifies the destruction that major earthquakes can cause. On the 19th of September 2017, at 1:14, the Puebla City earthquake struck, claiming 370 lives and leaving 6,000 people injured due to the earthquake and related building collapses. The first group challenge was to build a replica of a building that collapsed during the 2017 Puebla City earthquake. The building collapsed due to soft story failure, and as we can see, the ground floor is a car parking, which is typical of soft story buildings. When working in our groups, we decided to focus on having a strong foundation, so we used a lot of the resources provided in our first and second floor, and used cross bracing. Our building survived the earthquake simulation, however, it was beginning to fall apart under the lateral load and exposed the weak connections. Our takeaway from this task was that having a strong foundation was important, but having secure connections was also imperative. Geotechnical engineering. Earthquakes can cause soil to behave like a liquid, as under the load, dense soil sinks and the less dense soil rises. This is called liquefaction. This is solved by making soil more dense by using soil improvement techniques or building a foundation with extended foundation columns. Another aspect of geotechnical engineering is landslides, which is the movement of rock, earth, or debris down a sloped section of land. Landslides can also be instigated by earthquakes and can have devastating effects. We also simulated landslides as a part of the second component. We were tasked with finding the friction angle and repose angle of the granular material provided, then to determine the factor of safety compared to the 2017 Puebla City earthquake's peak ground acceleration.